Hi ladies, this is lesson 5.4 and it is factoring and solving polynomial equations. So in the last lesson, if you remember from 5.3, we were adding and subtracting and multiplying polynomials. Now we're going to do the reverse, which is dividing, and you can also refer to that as factoring. So some key vocab terms we have, if you look at your note sheet, the first term that we have is prime polynomial. Now we're going to define that in just a second, but we're going to move on to the other three terms. So we'll get to this prime polynomial because it's kind of a lengthy definition, but the factored completely is any time you can write the polynomial as the product of unfactorable polynomials. So think of like how you factored quadratic functions, or even maybe you factored linear functions, but writing it as the product of unfactorable polynomials, and you're going to use integer coefficients. We're going to do a new method called factored by grouping in this lesson. So we're grouping a pair of terms that have a common monomial factor, and then another grouping a pair of terms that has a common monomial factor, and we'll use that method to factor the polynomial. It does not have a common monomial factor, but may have a common binomial factor for all of the terms. And then quadratic form. So if you remember, our quadratic function in standard form was ax squared plus bx plus c. Well, quadratic form of a polynomial function is similar, but instead of that x, you have a u squared, where u is in any expression in x. So it has x in the expression, but it's not just the term x. So, for example, in this quartic function, 16x to the fourth minus 81, you can put that 16x to the fourth as 4x squared squared. Okay, so you can factor out that 16x to the fourth to be 4x squared, and you can factor it even beyond that, but it's 4x squared times 4x squared minus 81, and that's what we mean by quadratic form, where we have a squared binomial or trinomial, and then you're adding that to some term times that binomial or trinomial. So in this example, we would have u squared minus 81, where u squared is 4x squared. So 4x squared to the second power minus 81 is quadratic form of 16x to the fourth minus 81. Now looking at this definition of a polynomial, a prime polynomial, it's a polynomial with two or more terms is a prime polynomial if it cannot be written as a product of polynomials of lesser degree using only integer coefficients. So to factor it completely, we have to use integer coefficients, but a prime polynomial, we cannot do that. And the constants, if the only common factor of its terms are itself and 1. So for example, 16x squared minus 4x plus 8 is not a prime polynomial because 4 is a common factor of all its terms. So you could factor this out and you would get 4 times 4x squared minus x plus 2. Okay, so therefore it is not a prime polynomial. Now, if you look at the next section of your note sheet, a polynomial is factored completely, and we defined this above, but it's factored completely if it is written as a monomial, or the product of a monomial, in one or more unfactorable polynomials. So x plus 2 times the quantity x squared minus 5x plus 6 is not factored completely because you can still factor this trinomial. So x squared minus 5x plus 6, you can factor this as x minus 2 times x minus 3. So you would get factored completely, this would be x plus 3 times x minus 2 times x minus 3. Okay, so remember the rules about how to factor trinomials and binomials. Okay, so this section is not on your note sheet, but on your own, well, actually, let's do these together. To factor this polynomial completely, first we see that there's a common monomial in all of these. So that's where I would start, is to factor out the x. So we get x times x squared plus 2x minus 15. And then my next step, if it's factored completely, then I wouldn't be able to factor any of these any further, but I can, because x squared plus 2x minus 15, if I think of my factors of negative 15, I have negative 3 and 5, and if I add those together, I get positive 2. So it's x times x minus 3 times x minus 2. And that is factored completely. Okay, and then the next one, let's just look at this. And if you notice, you have a common monomial term, which in this case, y cubed is in both of these. So first factor that out. So y cubed, and you're left with 2y squared minus 18y. Then if I look at this again, I notice that I can also factor out a 2 from each of these. So I get 2y cubed times y squared minus 9. And then if I look at that y squared minus 9, those are both perfect squares. So I can factor that out. 2y cubed times y plus 3 times y minus 3. And then the last example, I notice I have a 4 in each of these and a z squared in each of these. So I'm going to factor out 4 z squared right away. And I'm left with z squared minus 4z plus 4. That's not quite factored completely, so I can go one step further, and I can factor that z squared minus 4z plus 4, where my factors of 4 are negative 2 and negative 2, and if I add those together, I get negative 4. So factored completely, I have 4z squared times z minus 2 squared. So again, for this section, if you're having trouble with factoring and you need to go back to factoring trinomials, then please practice with that, because it's gonna get more complicated as we factor larger polynomials. So remember your rules of factoring, and please come see me if you have any questions or need extra guidance. All right, this next section is like special factoring patterns similar to the ones that we did in the last unit that had multiplication, similar or common multiplication patterns when you were multiplying out your polynomials. So we have the sum of two cubes and we have the difference of two cubes. Now we've already talked about the sum of two squares and the difference of two squares, but now that we're getting into larger polynomials, these rules with cubes are often helpful as well. Right, so let's look at this sum of two cubes. So it has the rule there for you, a plus b times a squared minus ab plus b squared. So if you're applying this to x cubed plus 8, you get x plus 2 times x squared minus 2x plus 4. Then the difference of two cubes, you've got a cubed minus b cubed, a minus b times a squared plus ab plus b squared. So your difference of two cubes is 2x of 8x cubed is 2x minus 1. So this is your a is, well, yeah, your a is this term, 2x cubed minus 1 cubed. Okay, so here's your a, here's your b. So you've got 2x minus 1 times 4x squared plus 2x plus 1. So when you have these, it's important to first be able to identify what your a is and what your b is. Actually, I didn't identify this up here for you, but your a in this example is x because it's x cubed, and your b is 2 because 2 cubed is 8. So sometimes it's helpful just to rewrite it in cubic form so that you can see and apply those patterns a little more easily. All right, so try these two polynomials on your own. We did a couple of them together. Actually, we'll do these first two together again, and then you can try the third one on your own. So again, it's sometimes helpful to rewrite like what your cubes are, or what your a and what your b is. So in this first case, I can rewrite this as c cubed minus 5 cubed. So I'm looking at the difference of two cubes. So that's z minus 5 times z squared plus 5z plus 25. Okay, because again, if you go back to your rules, your kind of shortcuts, my a is z, my b is 5. And then and I have a difference of two cubes. So I've got a minus b times a squared plus a times b, or in this case I wrote it b times a, plus b squared. Okay, now let's look at this next one. And you're looking at the sum of two cubes, but first you may want to factor out that y. And actually, to get two cubes, you need to factor out more than just y, because 192 is not a perfect cube, and actually either is 81. So let's get it down so that they are perfect cubes. So looking at these two terms, you can see that both of them are divisible by 3, and you might have to play around with it for a little bit, and you'll get used to it, or you'll get more familiar with it the more practice you do. But you can see that they're both divisible by 3, and they both have a y value. Because we want to, again, get this in cubic form, since we're applying the sum of two cubes. So let's factor out a 3y from both of these, and you get 27y cubed plus 64. Okay, now let's write this in cubic form. So 3y times 27, which is 3 cubed. So 3y times 3y cubed plus the cubed root of 64 is 4. So we're saying 4 cubed. So here's the sum of our 2 cubes, where our A is 3y and our B is 4. Okay, so then when we write this, we write A minus B. Well, actually, this is the sum of 2 cubes. So we're going to write A plus B. A plus B. And it's times A squared plus AB plus B squared. Okay, so A squared is 3y squared, which is 9y squared, plus AB, which is 3y times 4, which is 12y, plus B squared, which is 16. But don't forget that you factored out this through y, so when you write it in your final answer, don't forget to include that 3y. And then here we have this factored completely because there are no, in this trinomial here, there are no common factors, there are no integer common factors with 9, 12, and 6. 3 is not 1, 4 is not 1, and there's not a y in every term. So this is then your final answer. Okay, try this next one on your own. Pause while you work, and then you can unpause for the solution. Okay, so here's what you should have. If you rewrite this in cubic form, you're looking for the sum of 2 cubes. So it's 2x cubed plus 4 cubed, and it gives you 2x plus 4 times 4x squared minus 8x plus 16. And this is not prime because you have, in all terms, you can factor out 2, and then in the second polynomial, you can factor out 4 for each of those. So it's not prime, but it's not factorable. So it is factored completely. It's just not prime. All right, let's look at this next section, factor by grouping. So this is a relatively new concept, and you're going to group 2 terms together that have common monomials. So in this first group, we've got x cubed minus 2x squared. We're going to group these 2 together because they both have an x squared term. And we're going to group those 2 together because you can factor 9 for both of those. So in the first group, let's factor out x squared. So we're left with x minus 2. And then in the second group, we're going to factor out a negative 9. So negative 9 divided by negative 9x divided by negative 9 is x. 18 divided by negative 9 is negative 2. So we're going to group terms together that have common monomials. And now, if you notice here, x minus 2 and x minus 2 are now common terms. Okay, so we're going to do the distributive property here. So we've got a different color pen. Okay, so we've got x minus 2, factor that out of both terms, times x squared minus 9. Okay, because here are the terms that are left. And then lastly, x squared minus 9 is not factored completely. We can use the difference of two squares rule. So we've got x minus 2 times x minus 3 times x plus 3. Because x minus 3, x plus 3, those are factors. Those are the factors of x squared minus 9. So we'll do a couple more of these together, and then you can try a couple on your own. But let's first look for common monomial terms. So we need to factor completely. So 16x to the fourth minus 256. Let's look for a common monomial term, and then we'll factor from that. So 16 and negative 256, they have a common factor, both of 16. So we're going to factor out 16 from both of those, and we get x to the fourth minus 16. Now we can factor x to the fourth minus 16 as our difference of two squares. So that's like 16 times x squared minus 4 squared. So 16 times the quantity x squared minus 4 squared is x to the fourth minus 16. Okay, so now to simplify this, to find the difference of perfect squares, we have our 16 already, and it's going to be times x squared minus 4. So x squared minus 4 times x squared plus 4. Okay, so this is a factor, but I have not factored completely because that middle term there can still be factored. So that's, again, the difference of two squares. So I get 16 times x minus 2 times x plus 2. And then x squared plus 4 cannot be factored. Okay, now let's look at the next one where you have 3y to the 7th minus 15y to the 5th plus 18y cubed. We want to factor out the largest monomial we can. And in this case, it happens to be 3y cubed. Okay, so let's first factor out 3y cubed from each term, and we end up with y to the fourth minus 5y squared plus 6. Right, now we want to look at factoring. The first one is fine, but let's look at factoring the second part of our polynomial, which is y to the fourth minus 5y squared plus 6. So if we rewrite this in a simpler form, we've got 3y cubed. That part is fine. But then we've got difference of perfect squares. So we've got y squared minus 3, y squared minus 2. Oops, should be 2. Because factors of 6 are 2 and 3, or negative 2 and 3. Factors of y to the fourth are y squared and y squared. So we want our m and n to add up to negative 5. So we need to use those negative factors of 6. So then this is our final answer. Okay, so take a minute to do these factoring. Pause the video while you work. And you can unpause and I'll show the solutions. All right, in this first example, we can factor by grouping. So we're going to group that x cubed plus 2x squared minus 5x minus 50 into two separate groups. So once we do that, we get x plus 2 as a common term in both, as a common factor in both terms. And then we get x squared minus 25. Now x squared minus 25 can be simplified because it's the difference of two perfect squares. So here's our final answer, x plus 2 times x plus 5 times x minus 5. Now if you look at the second example, you may have gotten stuck right away. So try rewriting it like this, okay? Because right now you cannot group because you don't have enough terms to group. But if you rewrite it as x to the 4th minus 5x squared minus 9x squared plus 45, it's the same thing, but now you can group. So once you've decided that, once you have terms in an order which allows you to group, you can factor out an x squared from the first two terms and a negative 9 from the second two terms. And notice that the first group, then once you factor x squared minus 9 times x squared minus 5, x squared minus 9 is the difference in two perfect squares, so you can factor that. So factored completely is x plus 3 times x minus 3 times x squared minus 5. All right, then these last couple examples are to solve the polynomial equation. So in this case, you are solving for x. So anytime we have to solve for x, we have to set the equation equal to 0, and then we're going to use the zero product property. So first, let's rewrite this equation. And then once you've rewritten the equation, then you can use some of the patterns that we've just looked at in order to factor it. So maybe it's factored by grouping, maybe it's the difference in perfect squares, or some other way, and then you're going to use the zero product property to actually solve for x. So in this equation, to start off, we can first factor out that x squared from just the first two terms, just to rewrite our equation. So this is like x to the 4th is x squared squared minus 10 x squared. So we're putting this in quadratic form where our u equals x squared. Okay, so we have u squared, a times u squared minus b times u plus whatever our c is. And in this case, our c is 9. Okay, so this is quadratic form of a polynomial function. And again, that helps just in order to factor so that eventually you can solve for x. Okay, so then if we start factoring, if you rewrite this, sometimes it's simple. It's more simple to rewrite it without so many exponents. So that would be like u squared minus 10u plus 9 equals 0. That looks a little bit more simple to factor. So if you want to rewrite it in quadratic form using u instead of x squared as your u, that's perfectly fine to do that. Just don't forget to change it back when you're solving. So this factors of 9, and again, you can do this how you want on the side, but factors of 9 are 3 and 3, which neither of those add up to negative 10, or you have negative 9, negative 1. Those add up to 10. So we've got u minus 9 times u minus 1 equals 0. But don't forget that our u is x squared. So let's write that how it should be. So it should be x squared minus 9, x squared minus 1 equals 0. And then you need to actually get this into its completely factored form. So that's x plus 3, x minus 3, and then x minus 1, x plus 1. So now we can use the zero product property to solve for x. So here, in order for this section to be 0, x would have to equal negative 3. Here, x would have to equal positive 3. Here, x would have to equal positive 1. And here, x would have to equal negative 1. So those are your solutions. When it says solve the polynomial equation, you have to actually solve for x. What could x be if that whole thing is equal to 0? Okay, so try this next one on your own. Factor out first any common monomial terms you see. Well, first get it in standard form, and then factor out any common monomial terms you see. Pause while you work, and unpause for the solution. Alright, so your first step is to set this equal to 0. Once you have set this equal to 0, then you need to put it in standard form. And then you need to factor out a common monomial, which is 2x. So then you're left with x to the 4th minus 7x squared plus 12. Now these are all even exponents, so you can put it in quadratic form. So assign a u value, and in this case, u is x squared. So it's x squared squared minus 7x squared plus 12. Okay, so then I just rewrote it in these next couple steps using the x squared term, but I put it back using the u term, but I put it back into x in case you did not do this step. So u is x squared, so I've got 2x times u squared minus 7u plus 12 equals 0. So you can check these next couple steps, and then again I substituted x squared back in for u. Okay, now I can still factor out that x squared minus 4. And now I need to use the zero product property. So using the zero product property, x has to be either 0, and that whole thing will be 0, or it has to be negative 2, which sets x plus 2 equal to 0, making this whole left side 0. Or x could be positive 2, or x could be plus or minus the square root of 3. So those are your real solutions for x. So please jot down any questions that you have. Go back and rewatch and rewind the video as needed. But please bring your questions to class or come see me one-on-one. Thank you.